In this topic, for standard form, we learn to write numbers in standard form. So exactly what is standard form and why do we want to write numbers in standard form? So let me introduce you the format of standard form first. So standard form looks like this. So I enlarge to explain to you the component. So standard form will look like this, where the power will be a whole number. The power must be an integer, which is essentially a whole number. So it can be positive or negative. So that's one of the conditions for standard form. And this number here got to be more than or equal to 1. But it must be less than 10. So it should be 1 to 9 point something, but you cannot equal to 10. So if I write it in inequality, it will look like this. Okay, so that's the two condition. So the two condition will be A must be in between 1 and 10, but it cannot be equal to 10. And the power here, the power of 10 must be a whole number. It cannot be fraction. It can be positive or negative whole number, but it can't be fraction. Okay, so why do we want to use standard form? Okay, when we got very large numbers or very small numbers, it'll be very useful. So very large numbers referring to numbers like maybe like 10 million, got a lot of zeros, so we can express in the standard form. Or very, very small numbers will be something like 0.00014. Okay, so one of the application of this topic is on cells. So sometimes you will see real world context where they talk about atoms and cells, where it's actually very, very small. So sometimes they describe the radius as a very, very small number because the cells is actually very small. Okay, so that's one of the application question that you will see. Okay, before we get to those questions, you must understand the prefix and also the condition for standard form first. So for the prefix, right, there will be certain prefix that we will use. So there will be something like kilo, 10 to the power 3, mega, 10 to the power 6, giga, 10 to the power 9, tera, 10 to the power 12. So if you realize, do you realize that there is a pattern? There is a pattern where the power is like 3, 6, 9, 12. Okay, so your syllabus will only cover 3, 6, 9, 12 for the positive power. Okay, so there is another, when we say kilo, it's also known as thousand. Mega is known as million. Giga is known as billion. Tera is known as trillion. So they are the same prefix, it's just that we can call it differently. So in a way, the syllabus cover 3, 6, 9, 12. Are there other prefix, right? Yes. There are other prefix. If you want, you can Google. There are prefix 15, prefix 18, okay, whatever you can try. So these are meant for the bigger number. So these are the prefix that are meant for the bigger number. For the smaller number, the prefix will be negative. So it will be like milli, 10 to the power minus 3. Okay. Micro, 10 to the power minus 6. Nano, 10 to the power minus 9. Pico, 10 to the power minus 12. Again, it covers 3, 6, 9, 12, but in a negative format. Okay, so another word will be thousand, million, billion, and trillion. Usually we will stick to the prefix here. Okay, so these are the few that you will need to know. Okay, so there are prefix for big numbers, there are prefix for smaller number. Okay, but before that, okay, let's explore first. How do we change numbers to standard form? Okay, so for example here, Okay, I lay out the steps, so let me try to explain the steps. So the first one, 25,900. So what are you supposed to do? If you look at step one, right, I'm supposed to move the decimal place. So currently, where's the decimal place? So currently the decimal place is here. So you're going to move to the left. 1, 2, 3, 4. You move until here, where you get a number between 1 to 10. So I move back 4 steps. I move back 4 steps. So I move 4 steps to the left. Then I get a 2.59. So it will be 2.59. The power will be positive. Positive what? Positive 4. Because you move 4 steps to the left. Okay. So if you want to do a check, right? You can do a check. You can do something like the primary school check. If you multiply 10 to the power of 4, that is like multiplying 1, 2, 3, 4. 40. So do you remember in primary school, when you try to multiply 40, you jump 4 places. So when you jump 4 places, you get back the same number. So you can always do a check back. Okay? So for a very big number, that's how you do. Okay, so let's try part B. Part B is a small number. Part B is a small number. So you are going to move the decimal place. So I'm going to move, okay, 3, 4, 5, 6. I'm going to move 6 steps to the right. So I move 6 steps to the right, and I managed to get 1.47. The power will be negative. It will be a -6. So when you see standard form with a negative power, that means it's actually a very, very small number. Okay? So that's how we can do it, or you can do it your way if you already got your certain way of doing it. Okay, so let's look at part C. Part C is 360 times 10 to the power -5. So how am I going to write it in standard form? So you target this one. You target the 360. Because 360 is not in standard form. Because it's more than 10. So you put the decimal is here. You move 2 spaces to the left. You move 2 spaces to the left. And you get a 3.60. So you move 2 steps to the left, you got 3.60 times 10 to the power of 2. The power is positive because you are moving to the left. And then don't forget the original 10 to the power -5. So whatever I'm doing here, I'm just doing it for 360. So in a way, 360 is 3.60 times 10 squared. So the final answer will need you to do a little bit of indices. So this one is same base multiplication. So you add the power. So that will be your final answer. You check, is the power a whole number? And is this number more than 1 and less than 10? Okay, so you target the number that is not standard form. So like, for example, the next one, 0.008 times 10 to the power 9. So you target this number because this number is not in standard form. It's too small already. So you move the decimal place 1, 2, 3 to the right, and you get a 8.0. 1, 2, 3 to the right, you get a 8.0. The power is -3. Okay, then don't forget the original 10 to the power 9. And then you do a bit of indices. Same base, you add up. So that is my standard form. Okay, alternatively, there is another method. Okay, let me show you another method for this time. So another method for part C can be like this. So I show you the alternate method. See whether you would like to do it this way or not. Some people will punch the calculator. Okay, so you try to punch the calculator. If you punch the calculator, it will actually give you 0.0036. So some people punch the whole thing on the calculator. Then from there, they change it to standard form. So they will get 3.6 times 10 to the power -3. So some people feel that it's easier. Yeah, you can do it this way as well. So if I do it for part D, I can also punch calculator first. Okay, I punch calculator, then I got 60 with it. So 60, the decimal place is here. You shift it backwards. You shift 6 steps to get 8.0. So the answer will be 8.0 times 10 to the power of 6. So some people feel that it's easier if you want to do this way. So I leave it up to you. Okay, you can like press it out first and then press it out. Then you change to standard form. Or you target the one that is not in standard form. Okay, it's your choice. You should still get it correct. Okay, then changing back to ordinary form is even easier. Changing back to ordinary form is totally easier. So for example, right here, this is a standard form that is equivalent to 100. So essentially, it's just telling you to shift the decimal place and you get 364. Then when you see 5.71 with 10 to the power -1, -1 is telling you to shift it back. So you shift the decimal place back, you will get 0.571. Or if you're not sure, you can just punch it out on your calculator. Okay, but whatever is it, negative power means you are is to show very small number. If it's positive power, it means that it's a very big number. Okay, so that is a general way of showing standard form. Okay. So let's say if it involves the operation, okay, if it involves the for operation, that means what happens when you do a multiplication of standard form? Okay, so what happens when you do a multiplication of the standard form? So for part A, so the question is telling you use a calculator to find the value, and then you give your answer in standard form. So what you should do is you just punch your calculator. Punch exactly what you see on your calculator. So in this case, it will give you something like this. So once you punch it out, then you change it to standard form. So once you punch it out, you change it to standard form. So by now you should be okay with shifting. So you shift back. So basically, I shift back 7 steps. I'm shifting to the left 7 steps. I get a 7.28. So that is my standard form. Okay, so basically it's a bit no trick. You just have to punch calculator. Then you show what is shown on your calculator. So you punch on your calculator. And then whatever that appear on your calculator, you write. Okay, and then you do the conversion. So I'm also shifting left. I shift 5 steps. So you'll be 10 to the power of 5. So basically, it's more like you punch calculator. Don't punch calculator wrongly. Okay, so punch calculator. Make sure you punch a few times to verify that you never punch wrongly. And then you change to standard form. So I move back 6. So I should then get 10 to the power 6. Okay, so for part D, same thing. You punch out everything. So this time around, you punch out, you get, maybe this one I just write here. You actually get 0.18730. So 0.18730. Then you jump forward 5 places. Oh, sorry. Here, I don't need to jump forward 5 places. I just need to jump 1 space. I will get 1.8730. So I just need to jump 1 space. I can have a standard form already. So I jump forward, the power will be a -1. So everything relies on how you convert ultimately and your punching of calculator. Okay, so try to practice this so that it's actually not difficult. The difficult one, we'll do it again in the subsequent example. So right now, this is the foundation. You must be very fluent in the conversion for standard form first.